it is defined as it is defined as the movement of fluid element, the movement of fluid element such a way that both of its axes horizontal and rotate in the same direction, and the rotation components are this is very important. Suppose rotation about x-axis half into dy minus dz, and this is the w into dv. This is the rotation about y, dz minus dx into du by y. Suppose how to remember it, x, y, z. Follow this one. Suppose x after x, y, z, and up sign is opposite, z, x equal to u, v, and w. The velocity component in x direction. This is the velocity component in y direction. So suppose this is rotation about y, after y z, then x, and the x direction, here the velocity component of x direction, and here velocity component of z direction, cos, just that. Now this is half into after z xy minus, and this is the y, this is v, and this is x, here this is u. Then, and when these components are zero, this is the irrotational flow or irrotation. And next topic is circulation. What is circulation? It is defined as the line. It is defined as the line integral of tangential component of velocity taken around a closed curve, a closed curve taken around a closed curve in a plane. It is denoted by this sign, circulation. The line integral, this is line integral for the closed curve. This is the circulation along the closed curve. This is the circulation along the closed curve. This is the line integral v. This is the scalar quantity. It is scalar quantity. It is scalar quantity. So vector v into ds. This is the length of the element. This is length, and this is the velocity column component of along the closed curve. This is the formula for circulation. Suppose this is the circulation, and this is the v, and this is theta. This is understand. Next topic is vorticity. It is denoted by this sign. Vorticity key. circulation per unit area, and another you can say it is defined as the value twice of rotation and it is given as 2 omega. So for wx we know, for x direction, twice into half into this is omega x 2 into this value is y minus z. This is v, and dv by dz. This is the vorticity. Understand? Oh, sorry. So vorticity equal to circulation per unit area. This is area A. Understand? Next topic is vortex flow. What is vortex flow? Flow of rotating mass of fluid. fluid. It is vortex flow. Flow of rotating mass of fluid, or flow of, or you can say flow of a fluid along the closed path. Now the vortex flows is vortex flow two type. One is free force. This force vortex flow. Force number one, vortex flow. Force vortex flow. This means the vortex flow is that type of vortex. Force vortex flow is that type of flow in which some external torque is required to rotate fluid mass. And fluid mass rotates fluid mass in this type of flow. This type of flow rotates with constant angular velocity, and the tangential component of tangential velocity v equal to omega into r, where r is the radial distance from f. This is the suppose container. This is the suppose r. This is the value of, this is the axis of rotation. This is filled with liquid. After rotating, this curve is parabolic, and now this is the radial distance from axis of rotation. So omega equal to v by r equal to constant. This is the relation between v and r for force vortex flow. Now examples of force vortex flow. Number one, flow of liquid inside the impeller of and inside the impeller of a centrifugal pump. Number two is a vertical cylinder containing liquid containing liquid which is rotates about, containing liquid which is rotated about its central axis, its central axis with constant angular velocity. This is the example. Next is number 2 is free vortex flow. It is the such type flow in which no torque is required to rotate fluid mass. Suppose m mass. Suppose a fluid particle mass of m at radial distance r from central of axis central of axis and having tangential velocity v. So angular momentum m into v, and moment of momentum mvr. So change in and rate of change of rate of time rate of change of angular momentum equal to d by mvr by dt. For free vortex flow, this value is dt d by mvr by dt equal to 0. And d, so integration both side mvr equal to constant, so vr equal to constant by m, so this value m, so constant. So for free vortex vr equal to constant, vr into constant. This is very for v, and for Force value, this is value is constant but not required. Next is examples of free vortex flow are free vortex flow. Suppose number 1, flow of liquid through a hole at, at the bottom of the container. At the bottom of the container. Number 2 is free vortex flow of liquid around circular bench in a pipe. Circular bend in a pipe. Note it down, please.